In 1931, as Thomas Edison lay dying, a proposal circulated through the highest levels of the U.S. government to honor him with a gesture of cosmic proportions. The president would order the national power grid to be switched off for 1 minute of symbolic darkness. The plan was scrapped almost immediately. Engineers realized that in the few decades since Edison's prime, the world had become so structurally dependent on the flow of electrons that 60 seconds of stillness would not be a tribute. It would be a catastrophe. It would trigger citywide blackouts, industrial failures, and mass social paralysis. This is the ultimate paradox of Thomas Edison. We are taught to remember him as the lone inventor of the light bulb, a narrative centered on the eureka moment of a solitary genius. But historical record and economic analysis suggest a far more cold-blooded reality. Edison did not invent the light bulb. By the time he filed his patents, dozens of versions already existed. He was not the most brilliant theorist of his age. Many of his contemporaries possessed a far deeper grasp of fundamental physics. Edison's true disruption was not scientific, but systemic. He was the first to realize that an invention is socially invisible until it is tethered to a monopoly of infrastructure. He didn't just sell a bulb, he sold the wires, the power stations, and the legal framework that made the bulb mandatory for modern life. Historians like Thomas P. Hughes, in his seminal work, Networks of Power, argue that Edison should be viewed not as a scientist but as a systems builder. Hughes notes that Edison's genius lay in heterogeneous engineering, the ability to manipulate not just physical matter but also legal patents, political lobbying, and financial markets. While his rivals were obsessed with the elegance of their circuits, Edison was obsessed with the architecture of the grid. He understood a brutal truth that still governs our world today. History is not won by the person with the better idea. It is won by the person who builds the system that makes the rival idea impossible to use. We are about to examine how a man with limited formal education managed to institutionalize creativity itself, creating a machine that manufactured progress at the cost of erasing everyone else who dared to build a different version of the future. In the mid-19th century, the American landscape was being forcibly redrawn by the iron spine of the railroad. This was not a world of academic laboratories, but of raw industrial velocity. On the Grand Trunk Railway, a young boy began his career not as an apprentice to a scientist, but as a news butcher, selling papers and snacks to passengers. This early exposure to the railroad is vital to understanding the Edison of later years. He was a product of the first network age, a world where value was defined by the speed of information and the control of distribution channels. The traditional narrative often dwells on his lack of formal schooling as a personal struggle, but viewed through a structural lens, this disconnection from the academy was a strategic divergence. Unburdened by the theoretical constraints of 19th century physics, he viewed electricity not as a mystery to be solved, but as a commodity to be moved. Much like the newspapers he sold on the trains, he spent his youth mastering the telegraph, the era's most critical infrastructure. The telegraph was the nervous system of the industrial world, and by mastering it, he learned how to compress time and distance into a marketable pulse of energy. Economists and historians such as Paul Israel in Edison, A Life of Invention, point out that Edison's time as a wandering telegrapher provided him with a unique technological literacy. While scholars were debating the fluid theories of electricity, Edison was on the front lines of the Victorian Internet. He saw firsthand how the Western Union monopoly operated, observing how patent control and infrastructure dominance were far more profitable than the technical elegance of the machines themselves. This period was his true education in the mechanics of corporate power. By the time he arrived in New York, his focus was already on the intersection of capital and technology. His first major success was not a tool for the public, but a tool for the market, a synchronized stock ticker. It was a device designed specifically to provide the financial elite with an informational advantage. He wasn't looking to change the world yet. He was looking to optimize the high-speed feedback loops of the Gilded Age's banking centers. This transition from a railway newsboy to a developer of financial hardware highlights a calculated trajectory. He recognized that in a rapidly industrializing society, power aggregates at the nodes where information is exchanged. His early patents were almost exclusively focused on improving the throughput of existing systems. He was building the tools that allowed capital to flow faster, and in doing so, he gained the patronage of the era's most powerful financiers, including J.P. Morgan. There is a persistent debate among business historians regarding Edison's early inventions. Many of the improvements he patented on the telegraph and the stock ticker were incremental rather than revolutionary. However, as noted by the Edison Papers Project at Rutgers University, his genius in this period was less about invention and more about commercial viability. He had an uncanny ability to identify technical bottlenecks that were costing banks and railroads money, and he positioned himself as the only person capable of clearing those blockages. The result was the creation of Menlo Park in 1876. While often romanticized as a laboratory of ideas, it functioned more like an industrial factory where the raw material was human intellect. He didn't just hire assistants, he hired specialized labor, mathematicians, glassblowers, and chemists, and organized them into a production line for intellectual property. This was the birth of R&D as an institutionalized force. The lone inventor was dead. The corporate innovation machine had begun, and its primary goal was to secure the patents necessary to gatekeep the coming century. In 1876, the establishment of Menlo Park marked a fundamental shift in the geography of human progress. It was not merely a laboratory, it was the world's first industrial research factory. Before this, invention was largely a cottage industry of idiosyncratic dreamers. Edison transformed it into a corporate department. He assembled a specialized workforce, the insomniacs, and directed them to operate as a singular intellectual machine. Here, the objective was not to understand the laws of nature, but to enclosure them within a framework of patents. The light bulb is the most famous output of this system, but to view it as a singular invention is to misunderstand the strategy. By 1879, Joseph Swan in England and others globally had already demonstrated carbon filament lamps. Edison's divergence was his realization that the bulb was a dead-end product without a centralized delivery mechanism. He spent as much time designing underground conduits, junction boxes, and meters as he did the vacuum seal of the lamp. He was building a captive market. To have light, the consumer had to enter into a permanent relationship with the Edison Electric Illuminating Company. Historical analysis by scholars like Jill Jonas in Empires of Light emphasizes that Edison's true breakthrough was his systemic vision. While rivals focused on the physics of the arc or the filament, Edison calculated the exact cost of copper wiring and the coal efficiency required to make gas lighting obsolete. His notebooks from this period are less full of sketches of light and more crowded with the math of urban density and capital expenditure. He was an architect of infrastructure disguised as a tinkerer. As the 1880s progressed, this system faced an existential threat: the emergence of alternating current, or AC. The War of Currents is often portrayed as a clash of egos between Edison and Nikola Tesla, but structurally it was a battle over the standardization of the American grid. Edison had invested massive capital into direct current, DC, which could only be transmitted over short distances. AC, championed by George Westinghouse and Tesla, allowed power to travel for miles. Edison's response to this technical inferiority was not a better circuit, but a campaign of institutionalized fear. He recognized that public perception is a component of power. He famously utilized the dangers of high-voltage AC in public demonstrations, going so far as to assist in the development of the electric chair, not as a humanitarian tool for execution, but as a branding exercise to associate his rival's current with death. The War of Currents remains a subject of intense debate among historians of technology. While popular culture often casts Edison as a villainous saboteur, some scholars, such as those contributing to the IEE Spectrum archives, suggest his resistance to AC was rooted in a genuine, albeit rigid, concern for safety in high-density urban environments. However, other analysts point out that the legal battles and propaganda were a standard industrial tactic of the Gilded Age, intended to protect the immense sunk costs of DC infrastructure rather than to advance the most efficient technology. By the end of this era, Menlo Park had proved its primary thesis. An idea is only as powerful as the institution that protects it. Edison had successfully shifted the locus of innovation from the discovery to the delivery. He didn't just win because his bulb worked, he won because he had already laid the tracks, signed the municipal contracts, and secured the funding to ensure that when the switch was flipped, it was his name on the billing invoice. The world didn't just become bright, it became a network, and Edison was the first to own the gate. The resolution of the 19th century power struggle did not result in a total victory for Edison's technology, but it secured a total victory for his methodology. By the 1890s, the boardrooms of Wall Street, led by J.P. Morgan, forcibly merged Edison General Electric with its rivals to form General Electric. In the process, Edison himself was sidelined from the very company that bore his name. This was the cold logic of the system he helped create. Once the infrastructure is standardized, the individual inventor becomes an overhead cost. Yet, even as his direct control waned, the world began to operate entirely on the Edison model of intellectual property and industrial persistence. The true consequence of Edison's career was the commodification of the intangible. Before him, an idea was a ghost. After him, it was a legal asset with a serial number. He moved beyond electricity to dominate the phonograph and motion picture industries, not by being the finest artist or musician, but by controlling the patents on the machines that captured sound and light. He understood that in a capitalist structure, the one who owns the bottle eventually dictates the price of the wine. The Motion Picture Patents Company, often called the Edison Trust, effectively decided what stories could be told on screen for years, forcing independent filmmakers to flee to a distant, sun-drenched outpost called Hollywood just to escape his legal reach. Economic historians like Robert Friedel and Paul Israel, in their analysis of the Edison effect, suggest that his most enduring legacy isn't any single device, but the invention factory. They argue that this model shifted the global economy toward a path where innovation is an institutionalized, predictable output of capital. While some scholars argue this accelerated human progress by decades, others, such as David Noble in America by Design, suggest it trapped scientific inquiry within the narrow confines of corporate profitability, prioritizing marketable technology over fundamental shifts that might have challenged existing power structures. Today, the world is illuminated by the alternating current of his rivals, yet we live in an Edisonian reality. Our lives are defined by proprietary ecosystems, software that only works on specific hardware, and grids that demand constant metered consumption. He provided the blueprint for the modern tech titan, the visionary who builds a platform so pervasive that it becomes indistinguishable from the environment itself. He proved that to win history, you do not need to be the smartest person in the room. You simply need to own the room and everyone's access to the door. The debate over Edison's legacy remains polarized. In the 21st century, there is a visible scholarly effort to rehabilitate the image of his rivals, like Tesla, who are often portrayed as the true geniuses. However, as noted by the Smithsonian Institution's curators, this often misses the point of 19th century history. The era was not a meritocracy of ideas, but a brutal competition of scalability. Historians increasingly view Edison not as a failed scientist or a thieving businessman, but as the primary architect of technological momentum, the theory that once a society invests enough capital into a specific system, that system becomes nearly impossible to replace, regardless of how many better ideas emerge. Edison died as one of the most famous men on Earth, not because he was the most liked, but because he was the most integrated. Every time we pay a utility bill, stream a film, or use a device that was designed in one country and assembled in another, we are participating in the system he codified. He did not just light the world, he gave it a rhythm, a relentless industrial heartbeat that values the reliability of the grid over the brilliance of the spark. In the final analysis, Thomas Edison's name survives not as a tribute to a single light bulb, but as the trademark for a new era of human organization. He was the man who realized that the most powerful thing one can invent is not a machine, but a process. By institutionalizing innovation, he removed the element of chance from progress and replaced it with the cold, predictable logic of the balance sheet. He shifted our civilization's definition of genius away from the solitary dreamer and toward the chief executive of a corporate laboratory. This transition left us with a complex inheritance. We live in a world of immense technical reliability, a world where darkness is defeated by a switch, and information moves with the speed of an electron. But this reliability was bought with the currency of consolidation. The Edison model ensured that technology would always be subservient to the grid, that the infrastructure would always prioritize the interests of the system over the radical potential of the individual idea. Modern sociologists and historians of science, such as those contributing to the Social Studies of Science journal, often point to Edison as the primary architect of path dependency. This is the theory that once a society commits to a specific technological system, like the centralized power grid, it becomes culturally and economically locked into that path, even if more efficient or sustainable alternatives exist. The debate is no longer about whether Edison was a good or bad man, but whether the systemic lock-in he created has limited the trajectory of human ingenuity to only what can be billed and metered. We must then confront a difficult intellectual tension. If history had favored the uncompromised brilliance of a Tesla or the independent spirit of a Swan, would we be further ahead, or would we still be waiting for the lights to turn on? Edison's career suggests that in the friction of the real world, a mediocre idea with a superior system will always outlast a superior idea with no system at all. He was the man who won history because he understood that history is not written by the person who discovers the fire, but by the person who builds the fireplace and sells the wood. As we look at the tech giants of the 21st century, those who own the platforms, the data, and the invisible wires of our digital lives, we are seeing the ghost of Menlo Park in every line of code. It raises a final, fundamental question about the nature of our progress. Does the system exist to serve the invention, or does the invention exist merely to sustain the system? If you were standing in the mud of Menlo Park in 1879, witnessing the birth of this industrial machine, would you have championed the brilliant individual? Or would you have bet on the man who was building the cage that would eventually hold the sun? Perhaps the most enduring lesson of Thomas Edison is that we don't just inhabit the world, we inhabit the systems that others have built for us. Would you have chosen differently, or is the grid we live in the only version of the future that was ever truly possible? Ultimate lesson from the life of Thomas Edison does not lie in his persistence or the 10,000 failed attempts to find a filament. Those are merely romanticized layers of history. The true systemic lesson is this: the value of an idea does not reside in its technical superiority, but in its compatibility with existing power structures and social infrastructure. Edison teaches us that to change the world, you cannot simply be a solver of scientific puzzles, you must be an architect of ecosystems. A discovery, no matter how advanced, be it Tesla's alternating current or Swan's light bulb, will be relegated to the margins if it lacks a grid, both literally and figuratively, in the form of finance, law, and politics to sustain it. Reality check. Evolutionary economist Christopher Freeman, in his research on national systems of innovation, pointed out that Edison's success is the earliest definitive proof of the transition from invention to innovation. While invention is merely the act of creating something new, innovation is the process of integrating that new thing into widespread use through commercialization and standardization. Edison understood that a patent was useless without a utility company to enforce its necessity. From this, we extract a harsh paradox of the industrial age. History often memorializes the one who holds the key to the system, rather than the one who drafted the most exquisite blueprint for the door. This forces us to reevaluate the tech giants of today, from social media conglomerates to AI pioneers. They are not necessarily the ones with the most humanitarian ideas or the most elegant code. They are the ones who built the grid into which we are all forced to plug our lives to function. This lesson leaves a vital question for anyone holding a new idea. Are you trying to build a better product, or are you trying to reshape the system that the product will inhabit? Because, as Edison proved, the person who controls the system is the person who ultimately controls the narrative of history.